Hi, I'm Xavier. Today I have another piece of equipment, and you know that I cannot resist. Yes, you guessed it. It's a new power supply, and I don't. You don't get enough power supplies on your lab. I mean, I have 4, 5, 6 power supplies, but no, I want one more, and this is gonna be the last one. Hopefully, because, geez, and this thing is a fucking beast. Whew. Okay, so this is a Philips model number PE 1647. It's a DC power supply, 75 volts, 14 amps. It's just crazy. It's a 1 kilowatts power supply basically, and yes, yes. The answer, the question, obviously, is yes. It's a linear power supply. Believe it or not, that fits in a free 19 inches rack mount unit. This is free units, and wow. I mean, this thing is massive. Look at the size of the terminals here. And there are terminals on the back as well, obviously, and this thing is just a beast. 75 volts all the way to 14 amps, and no, it's not limited because some power supplies they just says, oh well, 75 volts, 14 amps, but if you reach 20 volts, that's the maximum for voltage for the maximum current. So yeah, they just limit the voltage or the current. For example, 14 amps at maximum 20 volts of voltage. But no, this thing can actually go 14 amps at 75 volts. So I picked up this thing locally, and the guy was super nice, and he told me that this thing actually works, supposedly. I mean, this is for industrial application, I think. I actually have the manual for the whole thing, and yes, I've printed it, and yes, I have the manual for it. So with the full schematic and everything, look, it's just beautiful. Actually, Philips was actually bought, at least the test equipment manufacturing was bought by Fluke, I think. So yeah, now it's actually outdated, but geez, linear power supply, a 1 kilowatts linear power supply is just not something that you see every day. This actually weighs 38 kilograms. I had to weigh it because I couldn't really believe it was so heavy. So okay, so I'm actually going to try it out before opening, and see if it actually works or not, because and then obviously we're gonna actually open it up and see what's inside. And by the way, I just love the old-fashioned analog meters, and look at that. It's so great. Everything is so great, but geez, coarse and fine adjustment. I made course all the way from 0 to 75. Thank you very much. So you just pull this thing right out, and you go all the way to 75 volts, and this as well. So 0 to 14 amps. Alright, so I just connected to my switch box, outlet, whatever. And now it's time actually to see if this thing works. Alright, finger crossed. There must be a huge contactor inside. Oh. Alright, so it's standing here. 0.05. So the range of the fine, let's see here. Oh, yeah. For what is it? 800 millivolts, which is fair. Let's see here on the course, and yes, I made it. It's just 30 volts, 40, 50, 60, and all the way to 75.0. That's pretty spot on. I mean, geez, let's set to 50 volts. That must be 50 volts spot on the meter. That's 48.7. I mean, geez, this thing it's perfect. So let's see the currents. So let's go here to amps. Okay. So now it's already drawing 1 amp. Okay, there's some bad contacts, but geez. Okay, 1 amp, and we reach the limits here. Okay, so 1 amp, 2 amps, 3, 4, 5 amps, and it's pretty close. Yes, it's spot on. Perfect. Right, so as a quick test, just a little light bulb here. This is a 50 watts light bulb, and it just works. Yeah, no problems whatsoever. Alright, so it took a while, but I actually managed to tear it down and clean it. And won't really bother you with the video of me tearing down. Is, you know, not that interesting, I think. So here is the inside. As you can see, everything is oversized. There's massive transformers right there. There is a huge solenoid, which I think is the contactor for the mains. Huge heat sinks here for all the elements. Huge fan as well. Under here we have two huge capacitors for the output. So I had to first of all I had to clean it. It was full of crap inside and full of dust and whatever, because it's actually cooled by this fan here, and it's forced air, so there are no filters on the intake. So everything just comes in, and you know, dirt, crap, and dust, whatever. The construction inside is just so great. I mean, look at the huge wiring here. Everything is loomed together. There is another transformer here, one of those, you know, it's not toroidal, what is it? Another type of transformer. You don't really see those nowadays. It's just pretty old construction. But we have another transformer here. We have the control board, which is actually pretty simple. I mean, nothing too complicated. We have some operational amplifier and some other logic here to, you know, control the various. I think this actually works with thyristors and a transistor series regulated power supply to actually control the voltage and current simultaneously. So they are actually switching the thing. There are multiple devices. They seem to be TO3 packages, like 1, 2, 3, 4 packages. Under here there are some what seem to be huge diodes. I mean, this is a huge diode, and this is the main output. So I think this is the reverse polarity protection diode. And yeah, I mean, just look at the gauge of this wire here. Alright, sorry for the handheld camera, but this is the best way to show you everything inside. This is the main power supply transformer, and this is the huge contactor I was actually talking about. There is a huge solenoid inside, and I mean, look at that thing. I mean, jeez. And when you switch it on, it just vibrates everything. So great. And those are two, what I think, two huge ceramic, this is ceramic, fuse holders. And let me show you on the back. And look at that, I mean, wow. There is a tiny little fuse here, 220 volt, 0.2 amps, which I think is just the the fan or something, I don't know. And we have, yes, look at the ratings here. I mean, 220 volts, 25 amps, 110 volts, 50 amps. I mean, just incredible. And those are two fuse holders. This is the huge fan here. This is 115 volts, and yeah, I mean, it's just this fan alone is 50 watts. I mean, jeez. So the back terminals, big terminals, chunky, pretty good, and those are two the strip line here to actually have all the options here, you know, the sense wires and whatever, earth plug, and this is the specification here. Is 2.5 kilovolt amps, and again, sorry for the handheld camera. Those are two huge. There are two of those. Two huge capacitors. I mean, look at the size of this thing. It's just incredible. And I can't really see the ratings here. But geez, those are quite some beefy capacitors. There is another one here. Look at the you know, attention to details here. I mean, all the handles for the capacitors, and everything is just secured together, and the wires are very nicely loomed together, and those are the main output wires. I mean, look at that, there is the output capacitors right there. It's a 1500 microfarad. That's just incredible. Look at the main switch. It's just, everything is just oversized. And this is the little transformer. I think it's just for the control board. In fact, you can actually see those wires here, different tabs of the transformer just go in here, and there's a dead giveaway here. There's the main control board transformer, two bridge rectifiers here, and some capacitors for the regulation. It's just, yeah, for the control board. And at first glance, I thought that this heatsink, because this is an aluminum heatsink here, aluminum piece here, and was actually to, you know, sink all the heat for some components or devices that were actually under this shield. But apparently there is just nothing inside, so this is just for holding the whole unit together. We have the transformer for the control board, which is this one here, and we have the main transformer, this one here. It's the T26, and we also have some overlays right there. And yes, so this one is the main transformer. So here is the inductor, the huge inductor, and this is the main transformer going here, the bridge rectifier and whatever. And this is the other transformer here for the control board. Alright, so we have the control board right out and right here, and we can actually see here we have some regulation here. We have almost every chip you see here is LM741CN, which is a single operational amplifier, high gain, low noise. And look how many there are. I have 8 of those operational amplifiers. We have a LM324N classic quad operational amplifier right there. Interestingly, we have a little opto-isolator here, and a differential comparator right there. And interestingly, all the capacitors, obviously Philips, it's a very big company, and they make capacitors as well. They still actually make capacitors, and well, you know, every single capacitor in here is Philips branded. And here I took one of those fuses out. As you can see, they're quite heavy duty fuses. And this is a ceramic package by Weber, 25 amps, 500 volts. Look at this thing. Right, so I took the back cover off, and as you can see, in all its glory, the whole unit and the two huge capacitors. Look at this. I mean, it's just it's a strange kind of you know, format for a capacitor like this. I thought that they were actually round, but they're not. There's sort of a you know, squeezed. There are some angles right there. I don't know why they actually made it like this, but anyways, those are two 100 volts 15,000 microfarad capacitors, and those are they look like to be connected in parallel, so double the capacity. And those are the two bleed resistors for the actual capacitors here for discharging them. Look at the size of those, and those are the main rectifying diodes here. This is the wire that comes directly from the transformer, as you can see. Huge diodes here, and this is the protection diode here, little diode, and this is the terminal. So the terminal is so the positive is directly connected to the actual to the actual heatsink. We have also a thermal switch as well, which is nice to see. And what else? Some other resistors here for the main devices. They're all under here. We have this terminal strip, which is the selection for the 220 or 115 volts. Alright, so I want to do a little test here, and I want to measure the ripple and the noise of this power supply. And as you can see, I put it right there, and with a little bit of trouble, but I finally managed to put it on the bench. As you can see, my setup is very simple. I have the power supply, which is connected to a load. In this case, I have a 60 watts light bulb, and I have the oscilloscope here to measure the actual noise. So you can actually see the setup here. I have one of those car lights here, and have a little fan here to keep it cool. Alright, so have here the oscilloscope connected, and I'm currently at 100 millivolts peak, per division. So let's crank up the current, and you'll hear quite a bit of noise from the power supply, but it's completely normal because the actual frame, metal frame, is actually vibrating. It's not really fixed up, so yeah, I have to put one of those a few of those little rubber feet under the power supply, so it won't vibrate anymore, but now it's just there. Alright. So you can actually hear the noise, and the light is fully lit, and you can actually see there is no noise whatsoever here on the power supply. There are some peaks here, but it's completely normal. I think they're due to the system here, because I have no isolated, or at least shielded cables and something. So you know, is my system there is actually producing those peaks is normal. So the noise here is very low, and currently I'm at is it 4 amps, 12 volts, 4 amps, and I'm in voltage limit mode, and as you expect, the noise figure will be much lower than in current regulation mode. So let's go in current regulation mode, and you will actually see an increase in the noise. So okay, so you can actually see it's much more visible now, but still, I mean, 10 millivolts per division. We are about let's stop it, and let's get some cursors here. Where the heck is the cursor? Okay, so we're talking about, yeah, 14-15 millivolts peak of noise, so nothing really special. Alright, so we are in single mode. I'm gonna switch the connect the power on and see if there are any overshoots here, and let's actually see. So we are at 2 volts per division, should go right there at 12 volts and not overshoot. Alright, 3, 2, 1. As you can see, it's low rise and no overshoot whatsoever. Okay, that's interesting. We have a little bit of ringing here, perhaps with the for the connection and whatever, but you can actually see this kind of slope is rising a little bit here and then going up, and it's a very slow rise. So here you can actually see a little bit better the very gentle rise here. As you can see, this is due to the connection, but you can actually see it very gentle here, charging the capacitor perhaps, and yeah, it's just very nice.